Hello to viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about ISRO's third launch pad that's being worked on right now. So let's dive deep into it. So what exactly is the problem that India is trying to solve here with third launch pad? Well, India wants to become a big player in space, and we need our own space station and our own manned mission. Now, again, the spacecraft that we're gonna use, Gaganyaan, it's a capsule design or a simple design. This right now will be launched on a modified version of GSLV Mark III, modified version of that. But that would be just what we call a stopgap solution. That's not the end game. End game is this puppy, next generation launch vehicle. Super effective name. So this puppy requires its own launch pad because again, it's almost like a SLS variant, so to say, like completely new, large scale for us. Not SLS level powerful. That's like 2-3 iterations down the line. That's what we have planned. Now, next generation launch vehicle is under construction right now, and all the future missions have already been planned. Like this is how again astronauts has been selected. The craft is already going through final testing and all that. So things are moving. So we need a infrastructure that can handle that. And right now, ISRO has wiggle room, so to say, meaning we are designing a new infrastructure rather than just adding on to things that was made in 70s. So we are making something that is more robust, scalable, and modular, meaning we are designing everything with enough wiggle room that we can wiggle in the future, hopefully. So that's the problem that we are trying to solve with third launchpad. So what exactly is the location of this puppy? This is Satish Dhawan Space Center. Here, exactly here, it's here. Now, this is in Shrikota, Andhra Pradesh, India. You have to understand there is only one state that is below it. Now, like, wait a minute, why didn't we go to the lowest point and we get maximum yeet capacity from the Earth's rotation? Yeah, there is a problem known as Sri Lanka. If we launch from there, that would be amazing from a velocity point of view, but it will go through Sri Lanka, and we are not China. China drops the rocket stages on its own people, so of course they will drop on Sri Lanka. We do not want to do that, cause an international incident. So this place was selected. Now, like, okay, we still have so much wiggle room. Well, problem is Tamil Nadu was like a hub kind of place, state, so to say, and it has a lot of high density public area, so to say. Like even Srikota, it's only 105 kilometers from a metropolitan known as Chennai. So if you go to Google Map and see this whole area, it's populated. So even though we want to go as low as possible, we can't really go. It's not there. So Srikota was selected as a as close as we can go and have enough free area, enough wiggle room to get things done. And this has been the backbone of ISRO from 1970s. So we selected it, and again, because we laid down the foundation so early on, the what you call expansion of civilization has been halted. It's like don't build it too close to it. We do like this government has almost written it off. That area is like that area is ISRO playground. Don't tamper with it. State government has also like, bro, let's not just put things there. So that's being worked out, and eastward launch gives you the speed boost. That's why we want to do in that direction. We do also have launch towers that are on Arabian Sea. That's rarely used. Sometimes it is used, but most of the time we throw things on the Bay of Bengal side. And the area is very remote, meaning it literally looks like Cape Canaveral. You cool there. You cool. Even if a rocket fully fueled go kaboom, it will not have any impact. So that is there. And pre-existing infrastructure was a must, because again, if you have to lay down railway line, you have to connect everything from day one. It's difficult. So given the fact that it's close enough to Chennai, we can have some heavy shipping, rail, and aircraft. All three can be connected, and I'm pretty sure there are other places also that can adequately adjust for this. So it's a very, what you call, time-tested location. We are just going with it. Now, this time ISRO is switching gears, so to say. Instead of going vertical, we are going horizontal. If you look into almost all other rockets that India deals with, including PSLV, GSLV, most of them are vertically stacked. Now, that was cool, awesome. And again, if you look into Saturn V, that was also vertically stacked. But once you are actually planning to build a big rocket, as in like big rocket, 100-meter kind of rocket, as in tall wise, the structure becomes a hassle. Like that structure ends up costing way too much. So if you want to spend the money on the rocket, we don't want to just have like infinite budget. That's unsustainable. So how do you make the program sustainable? You want an expensive rocket, so how do you save money? Save money on other auxiliary systems. So it allows us to keep the structure cost down for the horizontal pipeline, meaning this structure, next generation launch vehicle integration facility, Don't ask me why they call it NIF building. That NIF building is much cheaper, exponentially cheaper than it would have been if it was just like, 130-meter tall. So that's a long way. Like you can see, the crew access tower height is around 120 meters. So we are talking some tall boys. So this allows us to keep the cost down. We want to dump as much money as possible on the rocket, not on anything else. So this allows us to cut down cost on all the auxiliary infrastructure that we need. Cool. Transportation is much easier. Again, rail transportation, you look into SpaceX, they are also doing it. They have a rail going there. You look into Russian system, they also have a rail going there. So it's there. Now, be mindful, we are talking about some big rockets. So those require some heavy puppies, as in hydraulic systems. So right now, be mindful, this is a what you call a rough sketch out stage of the what you call contracting. So they do specify that you more or less need four for this cradle structure, and they will be 6 meter apart and 12-meter apart, like 6, 12. So but again, these are tentative, as in like this is ISRO's rough guideline, and then once the contractor actually gets into it, I'm pretty sure they're gonna work with ISRO to actually fine tune it. It's like, okay, where do we need it? Like, this is just like a starting point, so to say. And again, contractors generally do not design launch pad. They generally will like, okay, what do you want? Like, what is your requirement? What is your rocket? And we're gonna just wiggle things around it so it works. So that's the whole point of it. Hydraulic does need, be mindful, it's going to be powerful, because again, this bogie is going to break this carriage. There is a hinge bracket. This green part that you're seeing, that is bolted onto concrete. Now that directly does not have the right hole for the exhaust system. So there is a brace plate. That brace plate, the pink color plate, that is on top of rocket. Now, like, why it's on the cradle? Well, because different rocket will require different version of it. So launch pad has the one base one, and you bolt on top of it this pink one. Now this pink one will change based on the rocket. So if you have the tall rocket, you will just have the tall rocket. If you have tall rocket plus 2 side boosters, you will have this 3 system. So based on the requirement, that plate would be changed, and this will remain completely bolted on concrete. It's not going to move. That will be the fixed structure, and it's a big structure, like 27 meter by 19.2 meter. So it's a big, and it's almost 3 meter tall. So almost a single story building kind of thing, like a big beefy building. So it's there. And hydraulics are there, like basically it goes there, hinge locks it up, the pin is inserted, hydraulic just like basically this thing, hydraulic just goes. Now be mindful, rocket has to be designed for it. This is the reason why almost all other systems, they generally do not go like this. They generally build the rocket like this, even though single stage itself can easily be transported like this. And again, look into a space shuttle, there's also like stages are transported in that way, as in horizontal. But why the heck stacking has to be done in vertical? Joints had to be designed in such a way that it can deal with going from this to this. Because again, rockets are what we call weight sensitive, so we generally cut out every milligram of weight that is possible. Penalty doing this could put too much strain. So either you have to design a cradle that, like, braces it enough points that it's like, bro, I got you, or you can have a rocket that it can handle it. So Falcon 9, it's not just like, oh, take any rocket, take a ULA rocket and twist it. Yeah, it will go kaput. It's not designed for that. So the rocket has to be worked, or the cradle has to be worked. Ideally, both will be worked to, so one does not become too stupendously expensive. Because again, if you can reinforce the rocket, okay, cool, awesome. But penalty is you lose payload. So what is more expensive, the cradle cost or the payload penalty? You have to balance those things out. So this will allow us to have basically expensive rocket, but cheaper integration, cheaper infrastructure that is on the, like, all the sidelines. So only the rocket is the expensive part. And again, almost all modern rockets are going this direction, because it's like vertical buildings looks cool, that Saturn V coming out of a building looks cool. It's expensive AF. It's not logical. It's way too expensive. Heck, the door itself is ludicrously expensive. So let alone having the whole structure, it's like, oof. And be mindful, we are close to sea. That does come with a penalty of cyclones. Now, here's the deal. That's just the rocket core part. But here's the deal. We also need a lot of support infrastructure. That's what makes a launch pad into a launch pad. So all those core items are taken care of, like water and tunnel. So we have overhead water tanks and a lot of water deluge system. Cool, awesome. And then we have a tunnel system. If you have looked into ULA system, the rocket goes whoosh, and there is a tunnel, almost like a concrete tunnel. And that tunnel funnels it out. And even though you have water, but that concrete tunnel is like making sure everything around it does not get affected. It's not like a naked system where you have like starship where it's going whoosh and everything else is exposed to it. No, there's a tunnel that is funneling it effectively. The most naked system is a Russian system where there is no water. It's just like a big ditch. How you are launching it? We put it on top of a big ditch and we launch it on a ditch. The end. And again, that's why that uh, uh, platform slid and fell. Why the heck a metal platform destroyed itself so quickly? Because it was at fall, like so. This time we are somewhere in between those things, basically completely dry system like a cosmodrome to basically completely wet systems. So this is a good medium ground, and it's a long tunnel, 113-meter long tunnel, 18 meter high and 25-meter wide. So it's a tunnel. It's like rocket will go whoosh, funnel it here, water will tamp everything down, and this opens up to the seaside. So that's for acoustic suppression. Now, one thing, if you have watched my videos long enough, you must have seen, I've kept saying that for some reason, Boca Chica still does not have air distillation unit. It does not make sense. It's stupid to pay money to bring trucks to bring that. It's like, why? Well, where they are getting it, like truck people, where are they getting the liquid cryogenics from? They are getting it from another air distillation unit. So you are paying for transportation unnecessarily. And again, if you know anything about diesel, diesel is not free. Trucks are not free. So again, the only reason why I can think of that why SpaceX has not sorted it is they do not have electricity there. Now it kind of makes sense because the infrastructure was designed for, like, small settlement. It was not designed for a giant rocket lab. And if you watched it long enough, you must have seen, like, they had almost no power, so they put solar. Then they had like gas well, they put some generators there, but those gas pressure was too low. And then they finally did, I think, 33 kV or 133 kV line. Then they finally actually got power. So I'm pretty sure they're still power limited. Otherwise, they would have done that. Cryogenic air separation plant, 50 metric ton per day. That's the tender that has been launched for ISRO for this site, meaning this place will have its own ability to make liquid oxygen and liquid nitrogen on site. Again, why pay for the trucks? It's wasteful. You are literally paying for someone's diesel unnecessarily. It's polluting and it's like unnecessary, wasteful, time consuming. So having this allows on site to be taken care of. Although I'm not sure what they're gonna do with argon. I'm pretty sure they can sell it. It's just, let's see what happens. So that tender is already out. And rocket lightning protection system, meaning they have ginormous towers that are surrounded. If you look into this map, zoom in, you'll find ginormous concrete pads that are bigger than the main rocket pad. It's like, why? Those are lightning arrestor, and those do not move. They do not, like, once you put it there, kaput, they will never move. So it is overbuilt to hell. And again, they are designed to tank lightning, and sometimes it's really bad because multiple lightning strikes happen. So those things are overbuilt to hell. It's like, lightning, I challenge you to a duel and you will get tired. That's how strong those things are built. And then we have components, which is liquid methane, hydrogen, and oxygen. So almost like what you have for Blue Origin. So some structures are dealing with oxygen, some are dealing with basically hydrogen, some are dealing with methane. And you also have cryogenic gaseous storage system. Wait a minute, we have cryogenic liquid. So why we have cryogenic gaseous? What does that mean? That simply means whenever you put liquid propellants, specifically this sort of super cryogenic system, for example, liquid hydrogen, it's boiling. No matter how cold it is, it's boiling from its point of view. So at the moment you put it in a tank, it boils. Now here's the, it is gas, but it's not hot gas. It's not like, okay, 100 degrees Celsius gas. It's not hot. It's still very cold. It just went through enough energy of like what you call phase change, but has not enough energy to be like hot gas or even ambient gas. So you have a different vent collection system, meaning all the rockets have the ability to dump liquid and have the ability to collect gases that are pouring out of it. That gases, it goes into cryogenic gaseous storage system. That puppy handles it, and those gases have other purposes also. For example, you might boil off some amount of liquid cryogenic propellants before you start the rocket, and you just condition the tanks, condition the pipe, condition the everything. So because again, gas will, even though it's a cold gas, it will not directly drop the temperature. It has to flow for a long time to drop every temperature. So that's a much gentler thermal shock. Basically, engines can handle it, tanks can handle it. There won't be any issue with that. So that does require a completely separate infrastructure to deal with that. Liquid cryogenic, you have different structure for that. Gaseous handling system, it has a completely different infrastructure for that. And they also have nitrogen supply, because again, I'm pretty sure they will be using that for flushing, purging, turbine spool up, those sort of things, and overhead tank for water. So these are the support structure, and each of them I'm pretty sure are overbuilt to hell. Again, I have gone through tender document, but they're like huge tender document, man, like 2 to 300 pages. Oh no, 1200 pages tender documents. It's like it's brutally long. So I'm pretty sure they are designed in such a way that they can keep scaling it up to, like, the wiggle room is huge. So what can we expect in the future? Well, reality is not for today. This whole system is not being designed for today. It's not like, okay, we're going to build it today and launch it tomorrow. It can work at that, but the idea is for tomorrow also. Meaning today you start with this, and then when you grow, this will be there to handle you. It won't be like, okay, now we need to build a launchpad number 4. We will build it, but for cadence and not for that launchpad number 3 cannot handle it. That's the whole point. And crew testing, crew missions does require a base of operation, meaning you're going to launch from here, you're going to do your emergency escape experience here, you're going to have like final days before you launch into space will be here. So they do need some place like this is where you stand. Okay, cool. We got that training ground, we got that. And scope creep, this is designed in such a way, like the concretes are overbuilt. The platform is designed for like a rocket. If they are like, hey, rocket is 1200 tons, they're designing it for like, almost 3000 ton. It's like, bro, we got this. Like everything is overheld, like overstretched. So bigger, heavier rockets should not be an issue. We're like, bro, we got this, we good. So, and why we are building this much? Well, reality is India wants to be on the moon. Now again, it's not on right now, as in like right now I would say USA wants to be there. Just after that, again, depending on how things unfold, so let's say 28 is the target of USA, 30s is the target of China, 40s on 50s is the target of India. Now if India pulls it off, India will become the 4th nation that would do so. Now how big is that, right? 4th, like, does that matter? Well, that puts us above 198 nations on the planet. Many times people don't understand like how amazing India's ISRO is. Again, I don't like ISRO because I want it to fly, because I'm comparing it to the world's best. But again, if I were born in any other country, 198 countries, even those rich countries, you'll be like, bro, what the hell are we doing? So flat out, it's a good long-term plan, and ISRO has like clear direction. Slowly chip away at it, slowly keep building at it, and we're gonna go there. Not again, it's not a rushed priority. It's not like get it done today. It's more of like, let's build a foundation for it. So that's being there. And timeline for this pad is aggressive. Budget is tight, which again, almost all India there is 4,000 crore, give or take $500 million, give or half billion. Let's just put it that way. So it's not infinite money, but like it's not a chump change either, so to say. So it's there, the money is there, but it's a bit tight. And timeline is kind of impressive. This happened on January 2025. Now, like, okay, why I'm covering in December? Tenders are coming out now. So yeah, it does take time, because many of the tenders have design detail, like where the heck we're gonna put this, where the heck we're gonna, even the air conditioning units, they have surprisingly large amount of detail on the air conditioning unit. Almost like, we want you to build this box, this has to have this much cooling capacity, this much dehumidification capacity, all those things are sorted out, just build it. So many of those things would require ISRO to like actually start working on it. They would not work on it unless they have budget for it. So I'm pretty sure the 1 year, as in like from January to December, was spent on doing that and figuring out like what exactly do we need, what is the capacity we need for the tank, the capacity for air handling system, capacity for cryogenics, all of those things were sorted out. So it's going to be close call. Let's that be very clear, because next generation launch vehicle is being worked on. So it's going to be close. But again, the whole nation depends on it. So we are the end game now. So let's see how it unfolds in the upcoming 3 years. So this was my presentation on basically ISRO's 3rd launchpad that is under construction. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show my disappointment. Please leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.